In this video, we will create a Swarf toolpath. A Swarf toolpath cuts the walls defined by surfaces or chains with the side of the tool. To be able to disable the view of our stock model, ensure it's the only thing selected and click on the toggle toolpath display here. Create a multi-axis toolpath. Select Swarf as your toolpath style. Then select Tool. Select a 1/4 inch ball end mill from the tool library. Then enter in a comment. Click on Holder, then select the Open Library button. If Mastercam does not automatically open the tool library for you, enter this path into the file name here. Open up the ct40.holders file, then navigate to find the C4C40025 holder. Select Cut Pattern. The Walls area allows you to select the wall surfaces using the surface selection or by selecting the upper and lower rails created as geometry using the chain selection. Enable Chain, then click on the Select button to the right of it. Enable 3D, then select the Options button. Disable the color mask if needed, and change the sync mode to by branch. Select the OK button, and then select the lower rail starting here. Continue around the part if needed. Then end the chain and chain the upper railing in the same manner. Once complete, choose the OK button. Leave the cutting method set to one way, change the compensation type to computer, change the compensation direction to right, leave the compensation set to tip, and note the wall following method area here. The wall following method allows you to set the tolerance in which the toolpath will be generated. Change the distance to 0.05 inches. The cut tolerance value determines the accuracy of the toolpath and is also used to eliminate duplicate positions as a tolerance when compensating to surfaces. Change this to 0.001 inches. When the distance checkbox is deselected, Mastercam uses the cut tolerance you specify as a tolerance to fit tool positions to the surface based on the curvature of the surface. Otherwise, Mastercam uses the distance value as an absolute distance for the space between each tool position. Select Tool Axis Control. Enable Fanning. Change the fan distance to 0.5. Fanning creates vectors that are not perpendicular to the upper and lower rails. Angle increment is an angular measurement between adjacent tool vectors. An additional vector will be added to the toolpath when the angle between calculated vectors is greater than the angle increment value. Minimize corners in toolpath removes the vectors immediately before and after any corner in the toolpath. Enable this. Select Collision Control. Click on Surface to enable it. Then select the Select button to the right of Compensation Surfaces. Click on the Select button here to choose your surface, and select the floor surface here. Then hit the End Selection button. Choose the OK button. Then select Linking from the tree. Make sure your clearance is set to 4, your retract is set to 0.5, your feed plane is set to 0.1, and keep tool down within a percentage of your tool diameter to 300%. Expand linking and click on Entry Exit. Enable Entry Exit and enable an entry curve. Change the length to 80% and the thickness to 80%. Copy this down to the exit curve. Then select the OK button to generate this toolpath. Once the toolpath is generated, backplot and verify it. Select the backplot verify options first. Enable stock model. Choose the stock model that we created, then select the OK button. Then verify the part. Once complete, your part will appear as shown.